In this lecture, we will briefly talk about capacitor structure. Two commonly used types of capacitors are multilayer ceramic chip capacitors, short name is MLCC, and the polymer capacitor. Here's a simple structure comparison between MLCC and the polymer capacitors. On the left-hand side, MLCC structure looks like a chocolate sandwich cookie that contains dielectric in between the multiple layers of plates. On the other side, we have polymer capacitor. The polymer capacitor has an ice cream-like structure that has a terminal leads sticking out, filled by titanium powder, dielectric, polymer, and carbon. You can click this link and watch the video for more detailed information. Here's another close look at the structure of MLCC. In the middle, we have dielectric materials with two electrode plates inserted on both sides, finished by the termination at two ends. The advantages of MLCC are low equivalent resistance, ESR, low equivalent series inductance, ESL, good availabilities, no polarity, good reliability, wide temperature range. MLCC is good for both AC and DC voltage applications. The disadvantages of MLCC are usually they have relatively low capacitance. Voltage rating is relatively low as well. MLCC usually has a DC bias issue, meaning that the capacitance drops as DC bias voltage across capacitor increases. This may cause some limitations in high voltage applications. Also, MLCC may have aging problems and the piezo effect noise problems. Another commonly used capacitor is aluminum electrolytic capacitor. Here we have a structure of a through-hole aluminum electrolytic capacitor. Inside we can see two layers of aluminum foils and two layers paper spacers interleaved and wrapped around. One foil is for anode, the other foil is for cathode. Two inner aluminum foils are separated by dielectrics. Two foils have separate aluminum wound element tabs, which provide electric contacts. Eventually, these two tabs are connected to the termination using through-hole pins. On the bottom side, we have a rubber seal in black holding the termination pins. On the outside, there's an aluminum can with safety vent, usually on the top. In case the capacitor has a high pressure inside, pressure relief vent can open and release the pressure to avoid explosion. Outside the aluminum can is the insulating sleeve with markings and the company logo on it. On the top of the capacitor, it has an insulating end disc. For this particular capacitor, we have 470 microfarad, 450 amps, aluminum electrolytic capacitor, through-hole version with radial leads. It's also called snap-in terminal. ESR is 252 milliohm at frequency 100 Hz. Lifetime is 15,000 hours at 85 degrees C. Please refer to this link for more detailed information. Generally speaking, the advantages of aluminum electrolytic are high capacitance, high voltage, and good sourcing. Disadvantages are higher ESR, low ripple current, and low expected life under high temperature. This slide shows structure of a surface mount aluminum electrolytic capacitor. As shown in the picture, this is a 470 microfarad 16 volt DC minus 40 degrees C to 85 degrees C capacitor. The major difference is it uses surface mount leads for soldering on the PCB. Aluminum polymer capacitor is another popular choice. It has similar structure as aluminum electrolytic capacitor, except that the dielectric is solid polymer electrolyte. The advantages of polymer capacitor is low ESR, low ESL, high current ripple, good aging characteristics, good temperature properties. The drawbacks are limited availability, relatively low voltage, and relatively low capacitance. Thank you and see you next time.